Possible hints of alien life found on K2-18b. How excited should we be about this? The James Webb Space Telescope latest discovery is significant, but have we really found life on an alien world? Data from James Webb Space Telescope JWST has shown that an exoplanet around a star in the constellation Leo has some of the chemical markers that on Earth are associated with living organisms. But these are vague indications, so how likely is it that this exoplanet harbors alien life? Exoplanets are worlds that orbit stars other than the Sun. The planet in question is named K2-18b. It's also named because it was the first planet found to orbit the red dwarf star K2-18. There is a K2-18c as well, the second planet to be discovered. The star itself is dimmer and cooler than our Sun, meaning that to get the same level of light as we do on Earth, the planet would need to be much closer to its star than we are. The system is roughly 124 light years away, which is close to in astronomical terms. So what are conditions like on this exoplanet? This is a difficult question to answer. We have telescopes and techniques powerful enough to tell us what the star is like and how far away the exoplanet is, but we can't capture direct images of the planet. We can work out a few basics, however. Working out how much light hits K2-18b is important for assessing the planet's potential for life. K2-18b orbits closer to its star than Earth does. It's at roughly 16% of the distance from Earth to the Sun. Another measurement we need is the star's power output, the total amount of energy it radiates per second. K2-18's power output is 2.3% that of our Sun. Using geometry, we can work out that K2-18b receives about 1.22 kilowatts in solar power per square meter. That is similar to the 1.36 kilowatt of incoming light we receive here on Earth. Although there's less energy coming from K2-18, it evens out because the planet is closer. So far, so good. However, the incoming light calculation does not take into account clouds or how reflective the planet's surface is. When we consider life on other planets, a popular term to use is the habitable zone, which means that at an average surface temperature, water will be in a liquid state, as this condition is considered essential for life. In 2019, the Hubble Space Telescope determined that K2-18b showed signs of water vapor, suggesting that liquid water would be present on the surface. It's currently thought that there are large oceans on that planet. This caused a ripple of excitement at the time, but without further evidence, it was just an interesting result. And now we have reports that James Webb Telescope has identified carbon dioxide, methane, and possibly the compound dimethyl sulfide, DMS, in the atmosphere. The tentative detection of DMS is significant because it's only produced on Earth by algae. We currently know of no way it can be naturally produced without a life form. So is there life on K2-18b? All these indications seem to suggest that K2-18b might be the place to go to find alien life. It's not quite as simple as that, though, as we have no idea how accurate the results are. The method used to determine what is in the atmosphere of an exoplanet involves light from a different source, usually a star or a galaxy, passing through the edge of the atmosphere that is then observed by us. Any chemical compound will absorb light at specific wavelengths, which can then be identified. Imagine it as looking at a light bulb through a glass tumbler. You can see through it perfectly when empty. If you fill it with water, you can still see through it pretty well, but there are some optical effects and coloration, which are the equivalent of hydrogen and dust clouds in space. Now imagine you poured in red food dye. This might be the equivalent of the main chemical constituent in the planet's atmosphere. But most atmospheres are made up of many chemicals. The equivalent of looking for any one of them would be like pouring 50, likely many more colored food dyes in different amounts into your tumbler and trying to identify how much of one particular color is present. It's an incredibly difficult task when plenty of room for subjective assessment and errors. In addition, the light going through the atmosphere contains a signal of the star's chemical constituents, further complicating the analysis. Only a few years ago, there was a surge of interest in whether life existed on Venus, as observations had indicated the presence of phosphine gas, which couldn't be produced by microbes. However, this finding was later successfully refuted by several studies. If there can be confusion about what is in the atmosphere of a planet that's just next door in astronomical terms, it's easy to see why analyzing a planet that's many times further away is a difficult task. What can we take from this? The chances of life on exoplanet K2-18b are low but not impossible. These results will likely not change anybody's opinions or beliefs about extraterrestrial life. Instead, they do demonstrate the advanced ability to look into worlds that are not our own and find more information. The power of James Webb Space Telescope is not only in producing incredible pictures, but in providing more detailed and accurate data on celestial objects themselves. Knowing which exoplanets host water and which do not could provide information on how the Earth formed. Studying the atmospheres of gas giant exoplanets can inform the study of similar worlds in the solar system, such as Jupiter and Saturn. And identifying levels of CO2 indicates how an extreme greenhouse effect might affect a planet, and this is the real power of studying the composition of planetary atmospheres. Ian Whitaker, Senior Lecturer in Physics, Nottingham Trent University, and this was published on the Conversations under Creative Commons. This is on Unexplained Mysteries. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.